All right. Hi, everyone. Welcome back to the channel. My name is Nitish, and in this video, we're going to talk about Helm. This is a part one of the video where we'll be talking about the basics of Helm, like what is the problem that Helm is trying to solve, what are some of the Helm concepts that we really need to understand. For example, what are Helm charts, what are Helm releases, what are Helm repositories. We'll be also taking a look at some Helm commands like Helm search, Helm install, etc. Doing all of this, will be performing the demonstration so that you can see what I'm doing and you can perform the same steps while watching this video. The part 2 and part 3 are going to be pretty interesting and most important for you to watch, which is we'll be writing our own Helm chart. So we'll be seeing how to write our own Helm charts. The part 3 will be continuation of part 2. We'll be building a Go application and deploying it to multiple environments like dev, staging, prod, and we'll be seeing how Helm is used to deploy that Go application to multiple environments. I'm pretty sure if you watch this playlist till the very end, you will be having a very good understanding of Helm. Without any further delay, let's get started. So let's first of all understand what is the problem statement. Okay, so let's say that you built a Go application, any application. It can be in Java, it can be in Python, C, C++, whatever it could be. Tell me, how are you going to deploy this application on Kubernetes cluster? You are going to containerize this application first. Containerize this application first, right? How are you going to containerize this application? By writing the Docker file of it, right? By building the image of it. Once you have built that image and you have pushed it to your registry, all you're going to do is create the deployments, is create the Kubernetes manifest that would take this application to run on your cluster. So you will do what? You write the Kubernetes manifest. That's very simple. You write the Kubernetes manifest. Now, this application is working perfectly in your cluster. But in actual production, what happens is this application needs to be deployed on multiple environments like dev, staging, prod, and I don't know, a lot of environments that this application needs to go through. And what is happening is that, so for each of the environment, like let's say dev environment, there's going to be a Kubernetes cluster associated with it. Let's say there's a dev Kubernetes cluster. Then you need to deploy this application onto your staging Kubernetes cluster. Then you need to deploy this application on your prod Kubernetes cluster. And depending upon how many such environments are there, you will have to deploy this application to multiple Kubernetes cluster. How are you going to deploy this application? By eventually deploying those manifests, or by eventually applying those manifests to your Kubernetes cluster. But here's a twist. What happens is, in every sort of environment, you make some changes. For example, you want to say that in my dev environment, I only want to run 3 replicas. I just want to run 3 replicas. And then you say in my staging, I want to run 5 replicas. And in prod, you say I want to run 10 replicas. Then you come up with another statement. You say I want to set some environment variable like dev. Then for staging, I want to set the environment variable that my application using to staging. Then for prod, you want to say that I want to set the environment variable to prod. And this list continues over and over and over again. Okay, this is actually problem statement now. What is going to happen? Managing this Kubernetes manifest is becoming increasingly complex when you try to deploy your application to multiple environments. So here comes Helm for you. What is Helm going to say to you? Helm will be like, let's say first of all understand definition of Helm. Helm is doing what? Helm is the package manager for Kubernetes. What do you mean by package manager? Package manager means that is going to contain all sort of everything that it would take for your application to run in any cluster. It's going to package that for you. Okay, and it's going to deploy that inside your cluster. For example, a real application will contain a lot of manifests. Like it's going to take deployment, it's going to take services, it will have roles, it will have cluster roles, it will have role bindings. Okay, it will have volumes, PVCs, etc. It will have think of it, it will have all sort of things that it would take for your application to run. So managing all these deployments is increasingly complex across these environments, especially when you want to just make some minor tweaks around the environment. What will you do? Will you just go in each of these environments and make changes manually? Right? For example, you just go to the dev environment, you make the replicas to 3, then you do kubectl apply, then you do the replicas as 5 there, and then you change the environment, and then you do a lot of other stuff. This is manual stuff, and this is definitely not efficient. What is Helm saying to you? Helm is a package manager for Kubernetes. Helm says that I'm going to package all these Kubernetes manifests. I'm going to package all these Kubernetes manifests into something, into a tiny box, let's say, into a tiny box. Okay. So now let's say this is a box that Helm has eventually produced for you, where all of your Kubernetes manifests are lying here. Let's say deploy, let's say all these Kubernetes were lying here. Here you go. Awesome. So all these Kubernetes manifests were getting stored here. This is a box. What is this box eventually called as in terms of Helm? This is called as a chart. Okay. What is a chart? We'll talk about that. Don't worry. But Helm is going to say, I'm going to package all of this. So I'm going to package all of this. And if you want to make, and I'll let you deploy all of this box in different Kubernetes environments. Like this is your Kubernetes dev cluster, then there's this prod, then there's this staging, and there can be multiple environments. Helm is going to deploy it to every single Kubernetes cluster. But now you'll be like, Nitish, what about the configuration changes you were telling me about? For like, how is it solving this problem? Replicas as 3, environment as dev. So whenever Helm deploys something in your Kubernetes manifest, it's going to basically deploy it based on a default configuration. Where do you store this default configuration? We store it in a file called as values.yaml. Helm is going to package your Kubernetes resources. That's very simple. Then it's going to do what? It's going to template them. What do you mean by template them? Now think about this. When I say replicas as 3, and then in another environment replicas as 5, and then in another environment replicas as 10, there needs to be some sort of way to template these fields. Okay. What do I mean by template? Template simply means there's going to be a template. Like there's going to be a similar sort of template that any Kubernetes manifest, any Kubernetes resource can follow. And then we're going to provide our own default values, and that will be injected into that template. For example, there can be a template that says replicas as X. So any Kubernetes manifest who follows this template has this template field injected. They can simply just replace this X value. Instead of writing replicas is equal to 5, replicas is equal to 10. All they need to do is just say X is equal to 5, X is equal to 10, X is equal to 11, whatever it could be. Okay. So what Helm does is it's first going to package Kubernetes resources. It's going to template them. Then what is it going to do? It can also version them. For example, let's say you deployed the Helm chart across this dev Kubernetes cluster, then you deployed it across your staging Kubernetes cluster, then you deployed it on your prod, then you deployed it any cluster. Each application can have its own version, and each chart can have its own versions. And let's say something goes bad, something goes wrong. Helm can also let you install, upgrade, or roll back to previous chart version. Now let's talk about three important things. What are Helm charts? What is a repository, and what is release? Okay, these are the three important things that we need to talk about. What is a chart? It is also called as a Helm package. For your information, whenever you hear something called as Helm chart, Helm package, this is exactly the same. Okay, so what is a Helm chart? Helm chart is nothing but it just contains all your Kubernetes resources. Okay, this is containing all your Kubernetes resources. Very simple. For example, it can have your deployment, services, roles. This box is what we refer to as a chart. Everything that it would take for your application to run is what we refer to as a Helm chart. Got it? Now you have a Helm chart which is like bundle of Kubernetes manifest that for your application to run on the Kubernetes cluster. What is a repository? Now think of it. You have a chart. You need to store it somewhere. So where do you store it? Repository is a place where these charts are stored. Simple. What is a release? Let's talk about that. Whenever you install any chart in your Kubernetes cluster, what do you mean by installing a chart in your Kubernetes cluster? It means installing all this Kubernetes manifest, installing all the bundles of that Kubernetes manifest in your Kubernetes cluster. Okay. And when you have installed that chart or bundle of Kubernetes manifest in your Kubernetes cluster, this is called as a release. Okay, so what is a release? Release is simply an instance of a chart running in your cluster. So now you got to understand about three big terms, which was chart. It's nothing. It's just contain all your Kubernetes resources. You got to know about repository, which is nothing but place where all the charts are stored. And you got to know about release. Okay. Sounds good, right? Now it's time to do something very important. I'm going to show you what are Helm charts. Okay, how does it look like? We'll be taking a look at some basic commands and I'll let you know everything. So I'm taking an example of Argo CD project for here. Okay, don't worry about that. Think of Argo CD. If you don't know about Argo CD, don't panic. All you need to understand that Argo CD is what? Consider this Argo CD as a or your application. Okay, very simple. Now what maintainers have done, maintainers have written Helm charts for it. If I go to this project, if I go to this GitHub repository, github.com/argo project/argo helm, you go to the charts here and you will see there's something called as Argo CD. Okay, these are the Helm charts for Argo CD. They have given all the descriptions here. We don't understand what is it doing. You'll understand it right now. Let's first of all go to something called as templates folder. You see there happened. So what is going to happen in templates folder? Let me tell you. In templates folder, whenever you create a Helm chart, I'll tell you, we'll be creating our Helm charts in the next part, but I'm just telling you right now, whenever you create a Helm chart, okay, there's something going to be created called as templates. This template folder is going to contain all your Kubernetes manifest in a templated format. Okay, now let's talk about it. For example, you can see, think about it. Now you're like, Nitish, where are the manifests getting stored here? If I click any part here, you see these are the Kubernetes manifests. So you know Argo CD is the distributed system. So it has multiple components that it would take for your Argo CD to run in a cluster. For example, Argo CD has a component called as controller. Argo CD has a component called as app set controller. It has another controller. Okay, it has another component called as Dex. It has another component called as API server, and a lot of other components. So you have to write Kubernetes manifest for all these components separately. It means, let's say controller needs your cluster role, services, etc. Cluster role bindings, anything that it would take for your controller. You have to provide the same to app set controller. You have to provide more configuration to Dex. You have to provide API server to same configuration to API servers. Okay. That's what they have done. They have written all the Kubernetes manifest for each specific component. For example, in the application set, all it would take for your application set to run are these many configuration. What it would take for your repo server to run, it would take these many configuration. Let's take a look at any one. Let's take an example of deployment.yaml. You see here something, you will see, oh my God, what is this thing written? Okay, don't worry about that. We'll be talking about this in the part 2. Okay. But this is what you see is here a template. Nitish, how is labels here getting used as a template? Like, why would you use labels as a template? Let's say your application is running in a dev environment and you want to label that this application as app is equal to dev. Now the same application, when it runs in prod, you want to label it as app as prod. Now this application, when it is running in staging, you want to label it as app as prod, so that you can get a differentiation of what deployments are running in my each environment. Okay, then this is a very typical use case of why do you need templating in labels. Okay, similarly for annotations as well. How these have been written, we'll be talking about in the next video. How do I install this Helm chart? Okay, think about this thing first. This is a Helm chart of Argo CD. This might be getting stored somewhere, right? So this is actually getting stored, and I already mentioned it to you. Now you see a Helm chart. I already told you about that there needs to be a place where this chart needs to be stored. So it's going to be stored in a repository. In order to install this Argo CD Helm chart on my Kubernetes cluster, what do I need to do is first add that repository. Once that repository has been added, all I need to do is install that chart. That's it. Okay, so if I go through their README, they have given me the first instruction is how to add the repository. So I'm just going to copy this command and let's add this repository. If I say helm repo add, hold on, I can simply do this. Let's see. It says Argo has been added to the repositories. What was this command doing? Let's see. Helm repo add -h. It very simply saying to me that it's going to add a chart repository. So all that you needed to do was provide a name of the repository and URL where this repository is located. So what we did just now, we had a Helm repo add, we provided the name of the repository as Argo, and then we provided where the URL was. Once that's done, if I do Helm repo list, It's going to list me all the Helm repositories. What are repositories? Where the Helm charts are stored. Now there is Argo, but you'll be like, Nitesh, where can I see Argo CD Helm chart here? So in order to see what are the charts stored in a repository, you run the command helm search in the repository called as Argo. Enter. You see all these are the charts. There's a chart called as Argo, there's a chart called as Argo-CD, there's a chart called as Argo CI, there's a chart called as Argo Events, Argo Lite, Argo Rollouts, Workflows, Application Set, Apps, Image Updated, Notification, etc. What is this chart version? Chart version is nothing but it's a version of the chart. Okay. What is this app version? App version is the version of the application. For example, Argo CD has this Helm chart as a version this, but what is the actual version of the Argo CD in which is going to be getting installed by that chart? It's the version 3.2.3. Okay. Similarly goes for what is the description? Description is simply the Helm chart description. Now you have now what you do? You have the Argo CD Helm chart here. Let's try to install this. How are we going to do that? First of all, I'm going to create a new namespace called as Argo CD. I'm already there. All right, sounds good. Helm search repo Argo, and now I'm going to install this Argo CD. I'm going to install use helm install -h. Okay, let's see what this helm install command does for you. So helm install, it's going to install a chart archive, or it's basically going to install a Helm chart for you. So if I do helm install, now I need to provide a name. Okay, if I tell you, you can see that it's expecting do what? It's expecting a name of the chart, and it's then expecting the chart. It's basically expecting the the release name, and then it's expecting the chart. Okay, so I'm going to say Argo CD, and then where is the chart? It's in the Argo repository, Argo-CD. I hit the enter. All right, you see this getting installed. What you see here, it's a very interesting thing. You see all these instructions. I'll tell you where these instructions, how do you get these instructions? If I go to the charts here, if I go to Argo CD here, and I go to something called as in the templates, I go to a file called as notes.txt. All these content is what is getting displayed when you install a chart. Like in order to access a server UI, you have the following option. Here you will see it. In order to access the server UI, you have the following options. Okay, we'll be talking about this in the next video. How do you do that? But this is just the basics. So I'm just telling you how this is working. kubectl get pods. You can see everything is running well. If I tell you about kubectl get all, you see all these eventually components were getting installed. If I list all the config maps that were getting installed, you can see all these config maps. If you see all the roles that were getting role binding, you see all these roles are getting created. But now, how I'm going to deploy this application to my another cluster, let's say, or to the same cluster, but with some modifications? How I'm going to do that? I already told you, where do you store this default configuration? For example, let's take an example of a config map here. Let's take a look at a config map. kubectl config map Argo CDCM -o YAML. You see in the config map, we have provided these data fields. How are these data fields getting injected here? How are these data fields present here? Where do you define these data fields? Let's go to the Helm chart here of the Argo CD. You have something called as a values.yaml file. What is a values.yaml file? Values.yaml file is the file where you store the default configuration. If I pass no file to you, use everything that is in the values.yaml file to inject the values, whatever it would take. For example, how this is admin.enabled set to true here. If I search in the here admin.enabled, you see it was set to true here. Nitish, why was this getting only added in the config map? So if you see the documentation here, they have seen that these are the Argo configs. They are mentioning that any values that you put under this one are passed to Argo CD -cm config map. How they have done that, that's another question. But just for the documentation, I'm telling you, whatever you specify here, and then you install the chart again, it's automatically going to be reflected in your cluster. I'm going to copy this. I'm going to create my own files, values custom.yaml. What I'm going to do is, let me tell you, I'm going to change this admin.enable to false. This is a very bad security practice. You shouldn't be doing that. You shouldn't be disabling the admin access. Okay, and I'm going to set this exec.enable to true. Example. Okay, what we can do is we can simply upgrade a release. Let's say Helm upgrade. This is the release name, and then this is a repository. Let's see. All right, it has been deployed. If I say Helm ls, you can see this is Argo CD. It was already there, but this is a revision number. If I now look at the config map and I see here, you see it is set to false now, and you see exec.enable is set to true now. Understood? Now you make some changes. You did not have to go to all the Kubernetes manifest and make changes there. All you did was defined the configuration that was repetitive or that you want to change in a values.yaml file. And then now all you need to do is just change the values here. Okay. What if you want to roll back to previous version? This is a security breach. You don't want this thing to occur. Now you want to roll back to previous revision. All that you need to do is use the command called as helm rollback. Okay, so I want to roll back to how this chart was in the previous revision, which is 1. So I'm going to hit enter. So that chart has got released back to how it was previously. If I say kubectl get pods, it's now running in the state. If I see the kubectl get config map, again, you will see something now. You see admin.enabled has been set to true, exec.enabled has set to false. This is the exact how it was when I installed the chart. Sounds good? Now you can have your values for your dev. You can similarly have your configuration files for your staging environment. Very simple, right? This is this sort of demonstration, how we're going to write our own Helm chart. I'm going to tell you everything in the part 2. Very interesting video, but for now we're just sticking it to the basics. If you do something like Helm search -h, you will see something here. It has the 2 options. Either you can provide a repository or you can provide a hub. If you provide a hub, it's going to search for charts in the artifact hub. Let's take an example. What is artifact hub? So this is the artifact hub. Okay. So if I search here, let's say Helm search hub example, let's say if we want to search for Bitnami charts example, or Redis, whatever it could be. You see a lot of Helm charts are stored. What is artifact hub? Artifact hub is nothing. It's just a place which lists all the Helm charts from a dozen of different repositories for you. Okay. So for example, you can search in the hub for a chart called as WordPress. You see? All right. Now it's time to install that. So I want to first of all add the Bitnami here. I want to install the Bitnami repository. So I'm going to do that. Helm repo add Bitnami, and then I'm going to pass the URL for the Bitnami repository, which is this one, charts.bitnami.com/Bitnami. There you go. I'm adding this repository. All right. Now I just need to update this repository. So updating the repository means like if there have been some sort of updates that have happened to the Helm charts in that repository, make sure you fetch those updates before updating. And then all I need to do is search for, here you go. Then you search for the charts here, which is Bitnami WordPress. And then you install the my WordPress, which is Bitnami/WordPress. Sounds good? So you'll see this is getting installed. So, okay, before we wrap up this video, this is the Artifact Hub. You can eventually go to the Artifact Hub, search for repository, for example, search for Helm charts. For example, I search for Argo CD here. Okay, you see I am Argo CD here. It gives you instructions on how to install this Helm chart. It's saying you Helm install, then this is the release name. This is the URL that you can use. This is a chart version you're providing with the help of version flag. Then it's telling you what is a templates file. Okay, what are the template file that it has in this chart? What are the default values file that we're using here? Example, this is not the official chart. Okay, this is just on the Artifact Hub. A lot of people have charts and they push it to Artifact Hub so anyone can install it from here and things like that. So you can go through this Artifact Hub, see what is this about. You try to push your own Helm chart, but this is the basic video of what is Helm, what is the problem it's trying to solve. The second part is going to be pretty interesting. We'll be writing our own Helm chart. We'll be seeing what are these values.yaml file, what are these things like include, what is this common.tpl, what is this helpers.tpl. You'll also be seeing what is this chart.yaml. The final part of the video will be building a Go application. We'll be Dockerizing that. We'll be pushing it to a registry. We'll be deploying it to Kubernetes cluster, and then we'll be writing the Helm chart for that application in order to get it deployed to dev staging prod. So make sure you watch the part 2 and part 3 as well. And that's it. I hope you guys have liked this video. If you guys do, make sure you hit the like button, subscribe to the channel, and I'll see you in the next one.